Hello friends, welcome to our channel Knowledge Amplifier. So in our previous video, we already started discussion on windowing in Kafka stream processing using Faust framework. Just a quick recap. First we discussed that suppose we are having a time axis and we need to do some aggregation. Maybe for example, total sales across all the counters or shops for a particular company. Now suppose on 22nd February you got sale of 10 entities. Then on 23rd February, you got sale of 5 entities. On 24th of February, you got sale of 10 entities, like that, so on. So now if you are aggregating as a whole throughout the time axis total, like for example up to 24th, the total sale is 25. Like that, if you are always computing the grand total or cumulative total over that time period, then it might give you less insights about your sales. But rather, if you group your sale across different counters day wise, like on 22nd February, how much total sale happened across all the counters or shops. On 23rd February, how much happened. Like that, if you just split your whole time axis into small chunks or buckets, and within that bucket, whatever event occurred, for that if you are computing aggregation, then basically that gives us much more insights compared to overall aggregation, right? So that's why instead of doing global aggregation, we started computing windowed aggregation, and we discussed this same example just now what I discussed, right? That here we will compute daily window based total sales, and which is giving us much more information. And then we discussed one important window, that is tumbling window. So what happens in case of tumbling window? That is basically a fixed window and non-overlapping window. For example, we discussed this particular figure where suppose at 9 AM the window starts and we are keeping our window interval of 1 minute. So 9 AM to 9 AM 1 minute. Whatever events occurred, that we will aggregate. So see, first data point 5 came. So here if you are accumulating all these results and calculate sum, so first the outcome will be 5. Then when 3 came, 5 plus 3 it will be 8. And then when an event came with value 8, so 8 plus 8 it will be 16, right? Now here at 9 AM 1 minute the window ends because 1 minute is over. So new window starts between 9 AM 1 minute to 9 AM 2 minute. And in that the first event is 9. So when you are computing sum, it is 9. Then the data 2 came, 9 plus 2 it is 11, and the data point 8 came, 11 plus 8 that is 19. Then again new window starts, so again it got reduced to 0, and based on first event the sum value starts from 5 in this particular window, and like that it goes on, right? This is basically ideal scenario in case of tumbling window. Now in this particular video we are going to understand another very important concept related to this, and that is out of order events. Okay. What is that? Let us try to understand with one simple example. So suppose here we are having this set of events. Here capture time is basically Unix timestamp, and we have to write a Python code which will compute the total card speed for 1 second window interval. So suppose for example our window we are computing based on capture time. So already we discussed, right, that we are having time axis here and time axis we are splitting. So suppose in this particular use case the time axis is capture time. Okay, capture time we will be splitting into small buckets, and within one particular window, whatever data are coming, that aggregated value we will compute. Okay, so in this particular case, as you can see, the capture time is basically an Unix timestamp, and suppose we are aggregating based on 1 second. So first window will be 16785531455.0. That is basically this particular value I took. This is basically indicating the beginning of the window, and then maybe it will go to 16785531455.9. Okay, up to this it will go. This is one window. Within this window, whatever events is there, see, card speed 5 is there, card speed 3 is there, and card speed 8 is there. So 5 plus 3, 8, 8 plus 8, it is 16. So it will give you 16. Now the next window is starting from 16785531446.0. That is basically here. This capture time is started. This window will start and it will go to 16785531446.9, like that. So see, the windows are non-overlapping. The previous window finished as 45.9. The new window is starting at 46.0. So they are non-overlapping, and the interval between start time and end time is always fixed. That is 1 second interval we are keeping always, right? Now in this particular range, what will be the aggregated result if you compute? See here, 46 is starting here and it is going up to this, right? So 9 plus 2 that is 11, 11 plus 8 that is 19. Okay, in this way you can clearly say this is what the aggregated result will be, right? Now the question comes, what about out of order events? So what is that? Let us try to understand first. Okay, so as shown in this particular flow, suppose that way our sensor is capturing different card speed and it is sending to our Kafka. Capture time is basically when the card speed was captured. In this Unix timestamp, these 3 card speed captured, that's why it's sent like this. In this timestamp, these 3 card speed captured, that's why it's sent like this, like that. Okay. Now suppose after some time, when here 1678553149 is running as per Unix timestamp, that time one event came with car ID 16, car name Honda, car speed 5, and the capture time is 1678553145. Okay. This particular Unix timestamp you observe carefully. This is actually was appearing here. That particular Unix timestamp related window is already over. After 4546 came, after 4647 came, after 4748 came, and the current window is running at 49. That time some older events which actually should come in this particular place somewhere, that is coming when the current Unix timestamp is 49. And why such thing is possible? For example, the sensor data is generating that particular JSON data in real time and it is publishing to producer. Maybe for some reason the producer is down or there is some network issue for which the producer is not able to publish the data on time, right? This is a perfectly valid scenario. So in that case, what is happening? That this particular event is considered as out of ordered event. Okay, because it is not coming as per its expected position, right? Actually, if it comes in this particular place, then what we should get as aggregated result for that particular 45.0 to 45.9 within this particular window, what we should get as result? That is 5 plus 3, 8, 8 plus 8, it will be 16, 16 plus 5, that is basically 21. This we should get as total car speed. But because this particular event is not coming on time, so we are getting only these 3 result aggregation outcome, which is 5 plus 8, 8 plus 8, 16. But this 16 is wrong result. Actually, we should consider this particular car speed also, although it is out of order. But we need some mechanism using which we should consider the out of order event also up to a certain extent. Obviously, it is not like it will be delaying as long as possible, maybe 1 year or 2 years. No, not like that. But at least sometime we will wait just to make sure out of order events also it is computing. So that particular concept how to implement in programming, that we will discuss today in this particular video. But one thing from this particular discussion, I hope you are getting clearly that here if you consider tumbling window, so suppose you are storing car speed. So first what it will store, first value will be 5 if you consider the first window, then the 3 will come, then the 8 will come. Okay. In the current tumbling window, suppose if it is running at value 45, that is in this timestamp, then this is accumulation of data, right? Now the next tumbling window is started in the next second when this tumbling window will expire. Then the next tumbling window is started for the Unix timestamp 46 and it will accumulate 9, 2, 8. Okay, these 3 events it will accumulate. Okay, but for considering out of order events, it is not like the older window, it will expire then and there. In some memory or somewhere, it need to store this older accumulated data, right? Otherwise, when this particular out of order event will come, this will not get a chance to combine with its original window and give the actual result, right? So what ideally should happen in case of computation along with out of order event, that this particular window state I need to store somewhere. For example, in my memory I will store 5, 3, 8 is basically the value what we accumulated for 16785531145.0 to 16785531145.9. In this particular window range, I got this result. Now this result set I will store in memory for certain amount of time, so that in future if some out of order event comes which is falling in this range, I will just pad that at the end. Maybe I will put this particular data point also here, and then I will accumulate the overall result set and I will give the correct result, that is 21 instead of 16, right? So 2 things in case of out of order event handling. Number 1 will be, we need to define that particular time span for which the window state our system will be storing in the memory, so that it can consider all the out of order event what is coming in future and then aggregate the total result set. Maybe that is 1 second, 2 second or 60 second or 1 minute, that we need to configure that for how much time I will be holding my computation for considering out of order event. That is point number 1. And point number 2 is we need to store the window state in memory for computing out of order event. It is not like as soon as the window is over, I will erase the state of that particular window. So these are the two things what we need to consider while implementing out of order event. Now without any further delay, let us directly jump into the implementation section and let's see how we can handle this out of order event using Faust stream processing. Okay. So without any further delay, let me directly go to Amazon AWS Management Console, because this particular demo I want to show you with Kafka cluster running in EC2. Okay. So here I will go to EC2 and I will quickly launch one EC2 instance with T2 micro configuration. So I will go to instance, I will click on launch instance, and here Kafka cluster, maybe some name I can give, and then here T2 micro, that is fine. Key pair I can choose as existing key pair only. I want to allow all this traffics and all, and I will launch the instance, right? And I will go here. Here see it is in pending state. Just wait for a couple of seconds. So see our cluster is now up and running. I will go to the cluster. I will go to security group. I will click on the security group and I will make sure that in the inbound rule it will allow all traffic from all IPv4 location, right? So that no network issue will be getting. When you will move to production, that time you can make it secure and all. But as of now, we are understanding the concept, so that is fine. So here I can copy the public IPv4 and I can use putty to enter in this particular EC2 the next box on the next machine. The default login ID is EC2-user. So here see we entered. Now here I will change the setting little bit and I will keep this as 10 seconds, right? So that is done. Now to launch cluster, first what we need to do, we need to install Kafka. So I will do that quickly. Kafka installation is done, and then here what we are doing, we are unzipping that particular Kafka files whatever got downloaded. You can execute Java version to check whether Java is there in your Linux system or not. It is not there, but Java is required for running Kafka. So here what I will do, I will install Java. And then again we can check with Java -version whether it is installed or not. So if I am again executing Java version, see here it is giving me the output. That means it is perfectly fine. I can go inside that directory where Kafka is unzipped, and here I can start the zookeeper with its default properties. But I cannot start the server with its default properties, otherwise it will run only in its private IP. So what I will do, I will open the EC2 machine with WinSCP, and then there I will change the advertised listener in our server.properties. So username is EC2 user. I will take the key file for authentication. So here I entered in the EC2 machine. Here I can go to Kafka folder. Within that config is there. Within that here server properties is there. I will change the server properties little bit. So here if you see advertised listener is there, that one. Instead of your hostname, I will put the current EC2 instance public IP and I will close this one. Okay, that is done. Now here what we will do, we will open a new session by duplicating it, and here I will do EC2 user, and then here I will first execute this particular export command. All these things I discussed several times in my previous video, how to launch Kafka in EC2. So I am just going a little bit fast here. and then here I will execute server.context. Okay, there you will see that the Kafka broker or the server will run in its public IPC plain text 100.26.49.178:9092. That's what our public IP is, 100.26.49.178, right? So that is fine. Now here what I will do, I need to create a topic. So the topic name I am keeping car speed related to this particular project. I will duplicate the session. I will log in as EC2-user. Okay, right. And then here in the car speed, here I need to mention the bootstrap server. So I will provide the bootstrap server correctly, which is running in our public IP of EC2. So here I will paste that, and then here I will go to that directory, and then here I will execute Kafka topic.sh command to create the car speed topic in that Kafka which is running in EC2. Okay. So see, the car speed topic got created successfully. That is fine, right? And I will just make sure it is not having timeout issue. So here, okay, it is already configured as that is fine. Now here what I will do, let me discuss the code. So in the producer section, we are doing all the necessary imports. We are giving the topic name car speed. We are creating here custom partitioner, which will take the key part and it will divide by total number of existing partition. Based on remainder, it will move to different partition within the same topic, as simple as that. In the producer code, here we need to mention the bootstrap server. So here what I will do, I will copy the EC2 public IP and then paste that here, and then here we are configuring with custom partitioner. The list of cars we are passing as we used earlier also, and then here we are iterating in that list if the key value in this kind of index. Already I discussed in my previous video while discussing tumbling window why we need this kind of concept, just to make sure one window is expired and the next window starts. For that I am giving some sleep time if the E range is coming within this, or else I am simply publishing that message in the Kafka cluster, right? And then here we are keeping an infinite while loop using which we can publish some data by manually inserting from the terminal. Okay, so here it will take user input and then it will publish in the Kafka cluster. Okay, so this is a common producer. Now let me show you the consumer section where we need to handle two very important property. Number one is we need to make sure the data is getting stored in a particular memory place or somewhere for certain amount of time, so that out of order events also it will consider. Okay, right? So to do that, here what I have done, I have imported all the necessary modules. Then here cleanup interval and window expire both I kept as 60. That is for 60 seconds I will wait for out of order event, although my tumbling window is of 1 second. Okay, so what I mean to say is one particular window will start from 45.0, then it will wait only for 1 second as part of tumbling window property, that is 45.9. Within this range whatever is there, that is our actual tumbling window. But to handle out of order event, we will wait for 60 seconds just to consume the out of order data. If it is coming within that 60 seconds, we will consider that also within that particular correct window frame, and that also we will be considering in the computation. So after 60 seconds only, from that memory, that stored data will be cleaned up because window will expire after 60 seconds, right? Then here we are creating our first application pointing to the broker, where the broker is running in this public IP. Okay, right? And then here we are configuring the table cleanup interval equal to 60 seconds. As simple as that. In our previous video while discussing tumbling window, we took the same complex structure for our events, because that is how from producer it is getting published, which is having car ID, car name, car speed and capture time. Okay, that is there. Now what is window processor? I will come to that, no need to worry. Now here we are creating our topic from where the Kafka stream will consume the data using app.topic pointing to car speed. Okay, and value type is this kind of complex data we will be getting from Kafka topic, as simple as that. Now here we are creating the tumbling table. Tumbling table name we are giving car speed counter 1. The default value we are configuring as list. Okay, earlier we just used tumbling 1 to get the tumbling window, but this time we added some important parameter. Let me discuss that. What is on window close? We'll basically call a particular function where the function name is window processor in asynchronous manner in the back end when our expiry time will be over. So here if you see on window close, this particular property is only called when the window expires. For example, our tumbling window is having the width of 1 second. Okay, so ideally for 1 second it will compute all the result and then the window should expire. But here we are considering out of order event also. So we are waiting for 60 more seconds to absorb all the out of order data, right? So once that window is actually expired from the memory, that is after the expiry time, that is after 60 seconds, when the window will be actually erased from the memory, that time we want to call some function and we want to do some computation on that particular accumulated data over that window. If that kind of requirement you are getting, then here you can mention a function which will be called when the window will be actually expired. Okay, it is not like after 1 second it will call it. After 1 minute or after 60 seconds, based on your expiry time, it will call it. Okay, I hope you are getting it. Then here tumbling of 1 we have given, that means 1 second tumbling window only we are creating. But here we need to configure the expiry time. I told you, right, that to consider out of order event, we need to store the current window state somewhere in the memory. Otherwise, it will forget that it will go to next window. Then there is no meaning of absorbing the out of order data. We need to consider the out of order data in the same window actually where it should be coming. So for how much time it will wait, that here we are telling that for 60 seconds you wait, because window expire, this particular value is configured as 60 seconds. Okay. And then here, if you consider this particular discussion, I told you that the tumbling window we are creating based on capture time. Based on this particular property of our input message, we are computing tumbling window. That's why from 45.0 to 45.9, there is one window. From 46.0 to 46.9, there is second window and so on, right? Now, how we can tell first application that you create the tumbling window based on this particular configuration? That we can say with this particular property, that is relative to field, relative to capture time within our car speed data, what is coming from Kafka, which is basically this particular complex structure. Based on that, you create the tumbling window. Okay, I hope you got it. Now let me show you that when the window is closed or actually expired from the memory, then this particular function is called, right? So here I have minimized that. I will just make it bigger. So what we are doing here, it will be very clear to us once we understand what stream processing we are doing. So here if you see, we are calling our stream processor using app.agent. Here we are iterating in that stream. First what we are doing, suppose in tumbling table, there is a key called event. For that event key, whatever value part is there, that I am extracting in value list. Okay. Initially it will be empty when it is beginning. Then here what I am doing, whatever event or message we have captured from the Kafka input topic, that I am appending in this list, and then again I am writing back in that particular value part for that key in the tumbling table. Okay. So continuously reading and overwriting by appending one particular element in the list. That's all. And then here we are printing the tumbling window. Okay. Now here what is happening, the tumbling table will be having key is event and the value part it will be basically a list. That individual list element will be one message, whatever JSON data is getting published. Okay. So now it has stored one particular tumbling window state in the memory. Once that particular expiry time is over, the window processor is called. Now the window processor you have to write with these two arguments, key and event. In the key part, the second element if you extract it will be a tuple. The zeroth index for that tuple will indicate the start time of that particular window which just now expired, for which we are doing final computation after considering out of order events, and the end time will be basically the second element of the second element for our key. And in the events part, all our value part is stored. Okay. So for a particular window, we accumulated all the result in the value corresponding to the key event. So from that, I am just extracting car speed. Okay, because I need to compute the total car speed across a window. That's all. So I am iterating in a for loop. I am extracting the car speed. I am storing in a list, and then I am using some function to calculate the total value. And here I am printing the total car speed. I can write total car speed between start time and end time is this much. Okay, that way I am formatting. Even this particular result you can publish in a process topic. From that, using programming based consumer or using sync connector, you can publish the data in some external system from her dashboard can consume. Okay, so all I am doing here using this particular window processor is when the window is actually expires, this particular code will be called automatically and it will do that computation or aggregation. Okay, right? Now without any further delay, let me execute this particular code. So to execute the code, what I will do, I will use this particular command, first a main worker l info, and see here our zookeeper is running perfectly fine, broker is also running, and here we are having nothing running because just we use this particular console for creating topic. Okay, now here what I will do, I will start my first application. Let's see whether it is having any connection issue or not. So see here our worker is ready. Now I will start the producer. Okay. So here see first 3 events producer will publish with same capture time, then it will stop. Then next events like that. In the terminal, if you see here what is happening, it is aggregating that data. Car ID 1. Okay. Then because the next event is also coming within same window, so it is basically keeping that in a list. Like that it is going. Okay. So here see all the event got passed. Now what I will do, I will copy one particular car ID and I will pass one out of order event and we'll see what is happening at the end. Maybe car ID we can configure as 100 and the car speed I can keep as 10. Okay, I can hit an enter. So this is one of the out of order data. Another out of order data I can publish, for example, car ID is 90 and car speed is 1. Okay, then here we have passed. Okay, 2 out of order events we have passed. Actually, this particular event, if you see, it should come at 058.0 to 058.9 in that window. Where that window was? That window was actually here. But we have published here. This particular event we published after the current time is running at 063 window. That is 063.0 to 063.9 in that window when it is running. We published this particular event. Whereas this event is actually should be coming in this particular place. So obviously this is one out of order event. And this particular event also if you consider, here see we are sending at current timestamp 063, but here we are passing for 060. 060 window is available here. So this is also out of order event. We will see how this is handled. Okay. First let's observe in terminal what is coming. So here see first we publish this particular event car speed 5 for 058. That is car ID 1 came, then car ID 2, then car ID 3. All 3 events came in same window. If you see the terminal, first car ID 1 came in the list, then because the car ID 2 is also coming under same window, so it just appended in that list. Here see you can easily understand this is a list, and then even car ID 3 also is coming under same window. That's why it is appended again in that same list. Okay. Then the next window starts. Our next window is having car ID 4, 5, 6. See, all are having same timestamp, right? So if you go to terminal, see here our fresh window starts so that it is showing only one element in that list with car ID 4, then car ID 5 also appended, then here car ID 6 also appended. Then the window is over for 059, a new window starts for 060. If you see 060, it is also having 3 event, car ID 789. If you observe in the terminal, car ID 7 came, then here car ID 8 came, which got appended in that list because they are coming under same window, and then car ID 9 also came, and then our window is over. So the next window starts. Next window is having 4 events, that is car ID 10, 11, 12, 13. If you observe here, car ID 10 came, one single element, then here car ID 11 also got appended in that same list because that are in same event. Then here if you see car ID 12 also came, here see car ID 12, and then here we are having our car ID 13 also, right? Now this tumbling window is over. Next tumbling window starts for 062 Unix timestamp, which is having only 2 car ID 14 and 15. Okay. So if you see here, new tumbling window starts. So it is a fresh list, car ID 14 and car ID 15 came. Then our tumbling window is over because 1 second is over. It is coming under 63. In 63, there are 3 events, 16, 17, 18. Okay. So see here, if you observe, first it started with car ID 16 only in the new window. Then when car ID 17 came, it got appended in that same list because it is in the same window. And then here car ID 18 also came. Okay. So here currently this window is running at 063 as per our current tumbling window state, right? Then we suddenly published an out of order event which is belonging to 058. And now see the beauty. If you consider 058, here see that card ID was 100, right? Let's see what happened then. If you observe here, card ID 1, okay, which was actually belonging to 058 window, and where actually card ID 1, 2, 3 was there. See here 1, then card ID 2, then here card ID 3, and then here we are having card ID 100. So this particular window state which is belonging to card ID 1, 2, 3 for 058.0 to 058.9, within that range whatever window was there, that our first application has stored somewhere in memory, right? That's why when this particular out of order event we passed, that time we first understood that okay, the capture timestamp is 058. It should be going to that window where 1, 2, 3 card ID is sitting, right? So it appended that particular data with that particular batch, right? And then here if you see another one with card ID 90, we passed for capture time 060. For this particular 060 window, you see card ID 789. So this particular card ID 90, which is out of order event, that should be combined with card ID 789. Let's see that. See here, card ID 7, card ID 8, card ID 9, and this out of order event card ID 90 came in picture, right? And by that time, when suppose 1 minute is over, after that, when that particular expiry time is over, then finally in asynchronous manner, our window processor is getting called and it is computing the aggregated result over a particular window frame. Like 058 to 058.9, the total card speed is 26. Let's see that whether it is 26 or not. So for 058 to 058.9, the events are these three. So 5 plus 3, 8, 8 plus 8, 16. And apart from that, here also one more out of order event we passed with card speed 10. So 16 plus 10, it should be 26. See here it given 26. Now for this one, 059 to 059.9. If you observe here, see 059 for this window, 9 plus 2, that is 11, 11 plus 8, it is 19, right? So it is showing 19. Let's consider another out of order event for which window we pass, that is 060. If you see 060, if you don't consider the expiry time or if you don't consider out of order event, then for this window it will just return you 5 plus 1, 6, 6 plus 7, 13, right? But it should consider this particular event also where card speed is 1. So 13 plus 1, for this window the result should be 14, right? Let's see that if you observe 060 to 060.9, the outcome is 14, not 13, right? That is, this particular computation is considering the out of order event also. That is the beauty. Just we need to make sure we are configuring the cleanup interval for the table, for what time we want to consider as delay for out of order data, that we need to configure carefully. And once that particular window is expired, then at the end this particular function will be called, which will aggregate the result set. Okay, and currently we are just appending the data in that first application and computing the sum. Obviously you can understand for that particular window you can compute average, minima, maxima, whatever statistics is required you can compute using that. So window processor in asynchronous way calling and the expiry time is very important. I hope you are getting it. This is very important concept with respect to any stream processing, out of order event handling. Okay, it is a very challenging problem, but Faust has made it very simple for us to handle it. Just 2-3 parameters we need to configure properly and then it can be handled easily. All the codes I'll be providing in the description box or in the comment section. Please go through that, because if you play with it, if you learn the codes, you will get better feeling out of it, how I did the experiment, right? And if you have any further doubt, you can ask in the comment section. I will try to revert back ASAP. If you find this video helpful, then please like, share and comment, subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.